All right, settle in. Welcome back to the deep dive. Today we're wading into, well, a really fascinating space, but also kind of a tricky one.
Hmm.
It's this collision zone between the, incredible promise of AI for businesses and the very real, often super complex demands of data privacy and compliance.
Yeah, it's a tension point that's really defining how enterprises are trying to roll out AI right now.
Hmm.
We've got a collection of source material here that digs into the specifics of this dilemma.
Right.
How do companies actually use the power of AI when the very fuel it runs on their data is also like their most sensitive and tightly regulated asset?
Exactly. It feels like you've built this amazing rocket ship, right? Ready to go to new business heights, but the only fuel you can get is super volatile.
Right.
And it's stored in like 50 different vaults, each with different keys, and you need sign off from about 10 committees just to get a thimbleful. Our sources really focus on the legal, the ethical, well, process-wise anyway, and the operational compliance hurdles that companies are, hitting head on.
They really do. The material paints a pretty clear picture.
Yeah.
The potential of AI is huge. The hyper-personalization, big efficiency gains, finding insights you just couldn't see before.
Yeah.
But actually getting there, that's tied directly to data.
Yeah.
And that data is tangled up in laws, regulations, internal rules, all designed to protect privacy and security. So friction is inevitable.
Okay, so our mission for you in this deep dive is really to get a handle on this conflict. We're going to unpack the specific challenges laid out in this material, look at how things like GDPR or SOC2 actually show up as real-world problems. And importantly, we'll explore the strategies and the tools that some forward-thinking companies are using to, navigate this mess. We want you to walk away with a much clearer idea of what it really takes to do enterprise AI responsibly and, well, effectively in today's world.
Yeah, we're digging into the practical stuff, the moments where that AI ambition slams into compliance reality. It's about understanding the constraints, not just in theory, but seeing how they actually impact businesses based on what these sources describe.
Okay, so let's dive in at the beginning. The fundamental paradox that really underlies all of this, just as the sources lay it out, it's almost funny, it's so simple.
Well, what jumps out immediately from the material is this core need of modern AI. Models, especially the really powerful, complex ones driving innovation now, are just incredibly data hungry.
Right.
Their performance, their ability to spot those tiny patterns, make accurate predictions, generate useful stuff, it scales massively with the amount, the variety, the depth of the data they learn from.
Yeah.
Generally, more data means a better AI.
Yeah, it's like a student needing to read, I don't know, thousands of books to really get good at a subject.
Yeah.
The AI needs that massive input to learn and figure out its domain.
And here's the clash. As the sources really highlight, the data that's often most valuable for training these super smart AIs is precisely the data containing sensitive information. We're talking customer purchase histories, detailed browsing data, location info, personal identifiers, proprietary business data, financial records, even things like employee performance metrics. This isn't just generic public stuff. It's the really sensitive core of what a company knows.
Okay, so inside the company, you've got one group, data scientists, AI engineers, product teams, business leaders, basically shouting, "We need all the data. Give us everything you've got to build the best model." Their focus is innovation, capability.
Exactly. And then on the other side, you've got the legal team, compliance officers, security folks, the privacy office, often risk management too, all saying, whoa, hang on a second. That data's got personal info. It's regulated. It's a huge liability if it gets misused or breached. You can't just have free reign over it. Their focus is protection, risk, rules.
It sets up this really powerful internal conflict, doesn't it? The engine of innovation, AI, needs the very thing, sensitive data access, that the engine of protection, compliance, is designed to lock down.
And this isn't just some abstract debate. The sources really stress why this data is so sensitive. It's not just about checking boxes. Mishandling this stuff leads to serious real-world pain.
Like what?
Well, think about a major data breach where customer data used in an AI project gets out. First, you've got massive financial penalties. We've seen GDPR fines in the tens, even hundreds of millions.
Wow.
Then come the lawsuits from the people affected. Expensive, damaging. And beyond the money, there's the hit to your reputation. Customers lose trust, partners get wary, regulators watch you like a hawk. Rebuilding that trust, that takes ages, if you even can.
So the very data AI craves could literally sink your business if you mess up. That really is the core paradox. It's not just tech or legal. It's a fundamental strategic challenge.
Oh.
How do you build a data-driven business when the world is rightly focused on privacy?
Precisely. It forces companies to rethink everything, data strategy, access, even how they build the AI itself.
Okay, and speaking of rethinking, let's get into the specifics of regulations forcing this. Our sources point to GDPR as like a classic example of this regulatory friction.
Yeah, GDPR, the General Data Protection Regulation in the EU, is probably the best known one. And its impact goes way beyond Europe because so many businesses operate globally. It's a cornerstone law giving individuals strong rights over their personal data.
And these rights sort of push back against the old way of just using data however you wanted, which AI models might prefer.
Exactly. By design. The sources point out several key GDPR principles that create direct friction with typical AI workflows. One is transparency. You as a person have the right to know what data is collected about you, how it's used, and why. For AI systems that might infer new things about you from different data points, explaining that clearly in a privacy notice, that can get really complicated. How do you explain all the ways a complex algorithm might use someone's data?
So it's not enough to just do it. You have to be able to clearly tell the person whose data it is what you're doing.
Yes, precisely. Then there's purpose limitation. Data should only be collected for specific, explicit, legitimate reasons and not used later in ways that are incompatible with those original reasons. This is a big one for AI.
How so?
Well, say you collected customer data years ago just to process their orders. Now you want to use that same historical data to train a brand new AI model for, I don't know, predicting churn or hyper-personalizing ads. That might be seen as further processing incompatible with the original purpose. Unless you have a separate legal basis, like getting fresh consent specifically for that new AI purpose, you might be blocked from using that rich historical data set.
Ah, okay. So that immediately limits those massive historical data lakes that AI teams dream about training on.
It does. It forces a much more deliberate, permissioned approach to reusing data. Then you've got user control. GDPR gives people right, like accessing their data, fixing errors, restricting processing, and this is a big one, the right to erasure, the right to be forgotten. If someone asks you to delete their data, and that data was used to train a huge AI model, well, that's a massive technical headache. Do you have to retrain the whole model without their data? How do you even find and remove the influence of one person's data from a giant complex model? It's really not simple.
Sounds like a data management nightmare piled on top of an AI challenge.
It definitely can be.
Hmm.
But maybe the most pointed challenge for certain AIs, highlighted in the sources, is Article 22. This is the right not to be subject to automated decision-making, and tied to that, the right to explanation.
Okay, break that down.
It means individuals have the right not to have decisions made about them solely by automated means, no human involved, if that decision has legal or similarly significant effects. Think loan applications, insurance pricing, job screening.
High-stakes decision.
Exactly. And if such a decision is made, people generally have the right to get human intervention, state their case, and crucially, get an explanation for why the automated system made that decision about them.
And this is where the whole black box problem really bites, right?
Exactly. A lot of the most powerful AI techniques, especially deep neural networks, are incredibly complex. They learn through millions or billions of parameters interacting in ways that aren't easily interpretable by humans. You put data in, get a prediction out, but tracing why it made that specific prediction for that specific person can be almost impossible. It's effectively a black box.
So you can have this amazing accurate model, but you genuinely can't tell someone why it decided what it did about them.
Pretty much. And the sources give this really vivid example of the real-world fallout with an insurance company.
Oh, yeah. Tell us about that.
Okay, so this insurance company wanted to use advanced AI, probably a neural network, to make their risk scoring for new applicants more accurate and efficient. The model would take an applicant's details and spit out a risk score, directly impacting whether they got insurance and how much it cost.
Seems like a sensible use of AI on the face of it.
It does. But then a customer applied, got rejected solely based on the score from this automated AI model, and they exercised their right under GDPR Article 22. They demanded an explanation. Why did the model decide I was too risky?
And the company couldn't tell them because of the black box issue.
That's precisely what the source describes. Their data scientists could explain in general what factors the model looked at, age, location, claim history, whatever. They could explain the model's architecture. But they couldn't provide a specific, understandable reason how those factors combined inside that complex network to produce that particular risk score for that individual applicant. They couldn't point and say, your factor X was weighted this way because of Y, and combined with Z, it tipped the scale here due to calculation W.
Wow. That failure to explain must have put them in a really tough spot.
It did. big time. Because they couldn't meet that regulatory requirement for a meaningful explanation under Article 22, they were non-compliant. They were using a solely automated system for a significant decision without being able to explain its logic. The outcome reported, stark. They had to immediately stop using that powerful AI model for risk scoring.
They had to pull the plug. Seriously, all that investment, potentially years of work, just sidelined because they couldn't explain how it worked.
It's a really powerful illustration. The big takeaway here is that for AI making significant decisions about people, explainability can't be bolted on later. GDPR basically forces you to think about explainable AI, XAI, or interpretable models right from the start. It shows that responsible AI isn't just about accuracy. It's about building systems you can actually understand and justify, especially when they affect people's lives. It's about building trust through transparency, a core part of GDPR, and frankly, just good practice.
Okay, so that's GDPR focusing on individual rights, privacy, explainability. But the friction isn't just about those specific regulations, it's also operational. The sources bring up frameworks like SOC2.
Right, SOC2 system and organization controls too. So while GDPR is mainly about privacy rights for EU folks, SOC2 is a reporting framework focused on the security, availability, processing integrity, confidentiality, and privacy of customer data handled by service providers. It's super common, almost table stakes, for SaaS companies, cloud providers, anyone selling tech services to other businesses, especially big enterprises.
So it's less about what data you use, more about how securely and reliably you handle it.
Exactly. It requires companies to have detailed, documented internal controls and processes, and then they have to prove, through independent audits, especially a Type 2 audit checking controls over time, that those controls are actually working effectively.
Okay, so how does this bump up against AI development? Wouldn't AI teams want good security anyway?
Oh, absolutely they do. But the process of AI development, the way it often works, can clash with the very structured, documented, auditable controls that SOC2 demands. AI R&D often thrives on being agile, on rapid experiments, trying out different data sets, tweaking models, often in flexible environments, sandboxes or experimental setups.
So it's like the difference between a tightly controlled factory floor and a more freewheeling research lab.
That's a good analogy. The move fast and iterate culture, common in AI development, can be fundamentally at odds with the document every step, control all access, follow strict change management world needed to pass a SOC2 audit, especially when sensitive customer data gets used in those experimental sandboxes.
Ah, I see. And the sources have an example of a B2B SaaS company hitting this problem.
They do. This SaaS company was building new AI features, probably for analytics, for their enterprise clients, which meant naturally processing their clients' data. To build and test these AI features, their data scientists were using these AI sandboxes environments set up for playing around with models and data.
And these sandboxes had customer data in them.
Yep, test subsets, maybe even copies of customer data sets. So the company is going through its SOC2 Type 2 audit, which is critical for keeping their big enterprise customers happy and compliant themselves. The auditors come in and start looking at the security controls around these AI sandboxes.
And what did they find? Not good, I'm guessing.
Not good. They found inconsistent access controls. Now that could mean a few things. Maybe different developers had wildly different access levels to sensitive data without clear reasons or logs. Maybe the process for giving or taking away access wasn't standard. Maybe audit logging was patchy, who accessed what when. Or maybe the sandboxes just weren't secured to the same rigorous standard as the production systems.
So even though it was just a test environment, the lack of tight controls was a big deal for the audit.
Huge deal. From an SOC2 perspective, customer data is customer data, wherever it sits. Weak or inconsistent controls on sensitive data, even in dev, that's a major red flag for an auditor. The consequence, as the source details it, was that the SaaS company failed its SOC2 Type 2 audit.
Ouch. That's gotta hurt for a B2B SaaS provider.
What was the business fallout?
It was immediate and painful. Their biggest enterprise customer, who definitely relies on SOC2 reports for their own vendor risk management, found out about the audit failure. And as a direct result, they hit pause on renewing their contract.
Wow, they put a freeze on the business relationship. That sends a serious message. It's not just some bureaucratic checkbox. It hits the bottom line, customer trust. Potentially jeopardizes the whole business if others follow.
It's a perfect, if harsh, example. The key takeaway from this SOC2 story is that these operational frameworks demand solid, documented, consistently enforced controls everywhere sensitive data lives, including AI dev environments. Compliance isn't just an IT thing, it's a critical sales tool, especially for selling to big companies. Failing compliance undermines trust and costs real money. It shows that strong governance around AI workflows isn't just about avoiding fines, it's about building the foundation for business itself. Okay, so we've seen GDPR hitting privacy rights and SOC2 hitting operational controls. The sources also dig into a conflict that feels almost built into AI itself. The tension between wanting more data versus needing to minimize data.
Yeah, this is another really fundamental challenge identified. Like we said up front, many AI models just get better with more data. More examples help them learn better, spot nuances, generalize to new situations. If you're building a model to understand customers, having years of detailed interactions will usually beat having just a few weeks worth.
Right. More data, smarter model.
Usually.
Usually. But a core principle in tons of privacy laws, GDPR included, is data minimization. Basically, collect only the data you absolutely need for a specific stated purpose, keep it only as long as necessary for that purpose, and have a clear reason for holding on to anything.
So the AI team is saying, give me every click, every purchase, every interaction from the last 5 years. And the privacy team is going, actually, based on our policy and why we collected this, we can only keep it for 30 days, and you can only use this limited bit. That's exactly the conflict. It directly limits the potential power of AI. You have the tech to build something amazing, but the legal and privacy rules restrict access to the sheer volume of data it needs to really shine.
And the e-commerce recommendation engine example from the source really nails this, doesn't it?
It's a great case study. This e-commerce company wanted to use advanced AI, maybe something like a large language model or a deep learning recommender, to give super personalized product suggestions. The goal was to really understand individual tastes and predict what people would want next, driving sales and making customers happier.
Which absolutely needs tons of history, what people browsed, clicked, searched for, bought over time.
Exactly. That behavioral history is the fuel. But because of their privacy policy, probably driven by regulations and how they handled consent, they had to delete non-consented user interaction data after a really short time. The source specifically says just 30 days. If a user didn't actively agree to longer storage, poof, that rich history was gone after a month.
Oh, wow. 30 days. That's brutal for a recommender needing long-term patterns like seasonal buying or evolving interests.
It really is. A sophisticated model needs to see those longer arcs. So when this e-commerce firm tried to train their fancy AI model using only this rolling 30-day window of data, the performance just tanked.
How did that look in practice? What were the recommendations like?
They became generic, kind of irrelevant, not very timely. Instead of suggesting that niche item based on 6 months of browsing history, the model could only suggest bestsellers, or maybe stuff related to what you clicked on yesterday. It missed all the subtle signals that build a real personal profile over time. Effectiveness clicks, conversions, sales from recommendations, it all dropped significantly.
So the AI project, while technically possible, got effectively kneecapped by the data limits from privacy rules. It ended up being mediocre instead of groundbreaking.
That's exactly the point the source makes. It's a direct bottleneck on innovation. The tech potential was there, but the legal constraints on data availability starved the model. The big takeaway is that companies need to shift their thinking. Instead of building data-hungry AI and then trying to cram it into privacy rules, they need to design AI that's inherently privacy smart right from the start, exploring ways models can learn effectively without needing these huge centralized piles of long-term sensitive personal data.
Which will definitely get to those privacy-preserving techniques. But before we jump to solutions, there's another layer of data complexity the sources highlight: the global footprint.
Yes, that's right. In today's world, AI development rarely happens neatly within one country's borders. Cloud computing, which is pretty essential for the heavy lifting of training modern AI, is global by nature. You might have developers in India training models using data from European customers, all stored on servers in the US.
And moving data across borders,
Yeah.
that triggers a whole new set of rules, right?
Absolutely. Lots of countries and regions have data residency laws, basically saying certain types of data about their citizens have to stay physically within their borders or be processed locally, and then you layer on top of that rulings like Schrems II from the European Court of Justice. That one seriously complicated transferring personal data out of the EU, especially to the US.
Schrems II basically said just having standard contracts wasn't enough to guarantee EU-level protection when data went to the US because of concerns about US government surveillance.
That's a good summary. It meant companies had to do detailed assessments of U.S. law and, if needed, put in extra technical and organizational safeguards to make sure the data got protection equivalent to the EU's standard. That's a high bar, especially when using US-based cloud services.
So training an AI model using EU customer data on a server sitting in, say, Virginia, suddenly became a lot more complex legally.
A lot more complex. Even within the same global cloud provider, just shifting data from a European data center to a US one for processing or training could trigger these really demanding cross-border transfer rules. Trying to build that single global data lake for centralized AI training, that became a massive legal and logistical headache under these rules.
The global retailer example in the source really shows the real-world pain of this.
It does. A big global retailer wanted to train a large language model maybe for supply chain optimization or global marketing personalization or better chatbots. They had customer data from everywhere they operated. To handle the scale, they planned to use a major US-based cloud provider for the heavy-duty training.
Seems like standard procedure for large-scale AI, you'd think.
You would, but because they were planning to move and process customer data from their European operations over to the US, their legal and privacy teams flagged it immediately because of Schrems to second. They couldn't just flip the switch and start training. They had serious legal hurdles to clear regarding that EU to US data transfer.
So they hit a wall just based on where the data was coming from and where they wanted to crunch the numbers?
Exactly. It forced a deep dive into transfer mechanisms, risk assessments, supplementary measures, the whole 9 yards. Ultimately, the source says, they had to completely change their plan. They were forced to localize the processing of their EU customer data. That likely meant training separate models or using a different cloud region or even a different provider located within the EU.
Wow, that sounds like a massive architectural shift mid-project.
It was. It meant redesigning data flows, potentially setting up parallel processing pipelines for different regions, renegotiating cloud contracts, tons of legal and tech effort. And the consequence, a huge delay to the entire AI deployment. The source mentions an 8-month delay.
8 months, almost a year lost on their AI roadmap, all because of where the data lived and where the servers were. It really drives home how technical architecture choices for AI are now deeply intertwined with complex legal and compliance issues that have to be tackled up front.
It's a critical lesson. The takeaway is unavoidable. Data localization, residency rules, cross-border transfer complexities like Schrems to second, these aren't minor details. They have to be foundational considerations when you plan your AI infrastructure. Legal and privacy absolutely need a seat at the table from day one of architecting global AI systems if you want to avoid these incredibly expensive and time-consuming delays later on.
Okay, so we've covered regulations like GDPR, operational frameworks like SOC2, the data quantity versus minimization fight, and the global data location maze. The sources also point to something a bit more internal, maybe more human, the bureaucracy around ethics and its unintended side effects.
Yes, moving beyond just legal and security rules, there's the absolute vital need for ethical considerations in AI. As AI gets more powerful and impacts people's lives more directly, companies are, quite rightly, setting up ethics review boards and processes. They're trying to ensure fairness, prevent bias, think about societal impact, align AI with company values.
Which is totally necessary, right? A good thing.
Absolutely crucial. But as the sources point out, while the goal is essential, the process of ethical review can sometimes become a source of friction itself, especially in organizations maybe new to this or without clear, standard procedures, or maybe just overly cautious. Each AI project might feel like it's reinventing the wheel, requirements can be vague, review cycles can drag on. This administrative weight, this bureaucracy can really slow down the pace of innovation.
The AI in hiring example seems like a perfect case where ethics review is critical, but could easily get bogged down.
It is. The case study involves a tech company building an AI model to help screen job applicants. The model would analyze resumes, maybe cover letters, using NLP to flag promising candidates. Now, given all the known risks of bias in AI for hiring models, accidentally learning and amplifying past biases based on gender, race, etc., an ethics review here was non-negotiable.
Right, you absolutely have to check for bias in that scenario.
Exactly. So the company's ethics board rightly flagged it for a thorough review. They demanded fairness audits, extensive bias testing to make sure the model wasn't unfairly screening out certain groups, checks against diversity policies, all the right things.
Sounds comprehensive? Necessary, even.
It is necessary. But the source notes that going through all these crucial steps added significant time to the project timeline, specifically 5 months were added to the rollout schedule just for the ethics review and associated testing and mitigation work.
5 months just for the ethical review part. That's a long time in the tech world, especially if you're trying to get ahead.
It is. And the consequence reported in the source was that by the time the model finally got the green light, the company felt they had lost their competitive advantage. Maybe rivals had launched similar tools faster, or they missed a key hiring season. They felt that the essential ethical checks, while vital, had come at the cost of business speed and opportunity.
That perfectly captures the dilemma. You have to do these checks for responsible AI. But if the process itself isn't efficient, it creates a real business cost in lost time and momentum.
It's a critical point. The takeaway here is that organizations need to invest not just in having ethics reviews, but in making them efficient. This could mean clear procedures, maybe peered reviews based on risk, standard playbooks for common tasks like bias testing, better cross-functional collaboration to streamline things. The goal should be for governance to enable responsible innovation at pace, not paralyze it.
And the source also touches on what happens when official governance is too slow or feels too restrictive. You get the rise of shadow AI.
Ah, yes, the predictable and often quite risky outcome. When the official paths for using AI are perceived as too slow, too bureaucratic, or the approved tools feel too limited, employees and teams who are trying to get things done will inevitably look for workarounds. They'll bypass the official channels.
It's like the modern version of shadow IT people bringing in their own software or devices, but now applied to AI tools and data access.
Exactly that. Teams might start using public AI tools, think consumer chatbots, for tasks that actually involve sensitive company information. They might download open-source AI models off the internet without proper security checks or understanding the potential biases baked in. They might find ways to access sensitive data outside the approved control platforms.
And the risks there must be huge. Data leaks, security holes, using bias models without realizing it.
All of the above, and more. Feeding sensitive company data into a public LLM could mean exposing trade secrets or customer PII to the third party you have no control over. That open-source model might have hidden vulnerabilities. Accessing data outside controlled systems throws all those SOC2 controls out the window. No tracking, no security oversight. It creates massive security risks, compliance nightmares, legal liabilities, and potential reputation damage, often happening completely unseen by the official IT or security teams.
The marketing team example in the source sounds very plausible and really highlights this risk.
It does. The source describes a marketing team needing to generate campaign copy fast. They saw how good a public LLM, like a widely available chatbot, was at writing text, so they started using it. The big mistake, highlighted in the source, was feeding it sensitive internal customer personas as prompts.
Wait, so they were putting details about specific customer segments, maybe demographics, behaviors, needs, into a public tool not approved for that kind of confidential data.
Precisely. They probably weren't trying to be malicious. They were just trying to be productive, treating the AI like a clever writing assistant. But doing that violated internal policy about handling sensitive info with external tools. They potentially exposed proprietary business intelligence, those detailed personas, and maybe even embedded PII to the third-party company running the public LLM.
And what happened when this came to light?
It triggered a compliance investigation. The company had to figure out what data might have leaked, assess the potential regulatory fallout, and deal with the internal policy breach. It's a perfect example of how trying to use AI efficiently, but doing it outside approved channels, can blow up into a significant risk.
It really underlines that human factor people trying to get their jobs done will find ways. If you don't provide approved, reasonably easy, and safe ways to leverage AI, they will find unapproved and often unsafe ways.
That's the core lesson from the shadow AI part. Delays, bureaucracy, or overly restrictive policies in official AI programs don't actually stop AI use. They just push it underground where it's uncontrolled and dangerous. A key risk mitigation strategy is actually empowering teams with approved, secure, and relatively efficient AI tools and processes. Make the official way the easier way.
Okay, wow. So we've spent a good chunk of time mapping out all these challenges, the data hunger versus sensitivity paradox, the hurdles from GDPR, SOC2, data minimization, global data rules, bureaucratic friction, shadow AI. It paints a pretty intimidating picture, honestly.
It can seem daunting, yeah.
But the source material doesn't just leave us there in the problem space, right? It pivots to exploring how companies are actually succeeding, how they're building that bridge between wanting to innovate with AI and needing to stay compliant and secure.
Exactly. This is where the focus shifts towards solutions and more forward-thinking strategies. The material highlights that the companies really making progress aren't trying to fight or ignore these challenges. Instead, they're weaving privacy and compliance right into the basic design of their AI systems and their processes. They're starting to see these constraints not just as roadblocks, but as design requirements that actually push them towards smarter, more secure, and ultimately more trustworthy AI.
Okay, so what are some of these specific techniques and strategies that the sources say are actually working?
Several key technical approaches come up repeatedly. One big one is synthetic data. The idea here is, instead of training your models on real sensitive personal data, you create artificial data. This fake data is designed to mimic the statistical properties, the patterns, the relationships found in the real data. But critically, it contains zero actual information about real individuals.
Huh. So the AI learns from data that looks and acts like the real stuff, statistically speaking, but isn't actually anyone's real information.
Exactly. There are specialized tools and platforms now focused on generating high-fidelity synthetic data that keeps the analytical value you need for training, but without the privacy baggage. This directly tackles that data minimization problem. You can generate large volumes of safe synthetic data to train your models effectively without hoarding massive amounts of sensitive personal data long-term.
That sounds like it could be a real game changer for a lot of AI projects stuck on data access.
It definitely has huge potential. Another powerful technique mentioned is federated learning. This is especially useful when your sensitive data is naturally spread out maybe across different departments or partner companies or even user devices, and you can't easily pull it all into one central place because of privacy rules or data residency laws.
Right. So how does that work if you can't bring the data together?
Well, instead of bringing the data to one central model, you send the model, or more accurately, the training process, and updates out to where the data lives. The AI model gets trained locally on the data sitting on that device or server inside its secure environment. Only the insights learned, like aggregated parameter updates, not the raw data itself, get sent back to a central server to be combined into a better global model. The sensitive data never leaves its original protected location.
Ah, okay. The algorithm travels, but the data stays put. That's pretty elegant. It seems to neatly solve the data centralization and cross-border transfer problems for distributed data.
It really does. It's a privacy-preserving architecture by its very nature. Then there's differential privacy. This is a bit more mathematical. The idea is to add carefully calculated statistical noise or randomness either to the dataset itself before analysis or to the outputs of queries or model training. The goal is to make it mathematically very difficult, practically impossible, to learn anything specific about any single individual in the data while still allowing you to get accurate results or train effective models when looking at the data overall in aggregate.
So it provides a kind of mathematical privacy guarantee for individuals while still letting you do useful group-level stuff.
That's the core concept. It makes anonymization much more robust. The sources also bring up data clean rooms. Think of these as secure, controlled digital environments, often provided as a service where multiple companies or maybe different divisions within one company can bring their data together to collaborate. They can run joint analyses or train shared AI models without any party ever getting to see the other party's raw, sensitive data directly.
So you get the benefit of combining datasets for richer insights, but without the risk of actually sharing the sensitive source data.
Exactly. The data goes into the secure room, approved computations happen inside the room under strict controls, and only aggregated privacy-safe results come out. Super valuable for partnerships, like between a retailer and a CPG brand, or even just for internal teams that shouldn't see each other's raw data.
Okay, and finally, circling back to that black box problem we talked about with GDPR, model explainability frameworks.
Yes, this is absolutely critical for tackling regulations like GDPR Article 22. These are tools and methods, part of the broader field of explainable AI or XAI, designed to help data scientists peek inside the black box and understand how an AI model reached a particular decision or prediction. Techniques like SHAPE or LIME can help attribute a model's output back to specific input features, giving you insights into the model's reasoning, even if the underlying math is super complex. This is what potentially allows companies to provide those required explanations for automated decisions.
So these tools are like giving data scientists flashlights to see inside the mechanics of the AI.
That's a good way to think about it.
Yeah.
They help make opaque models more transparent, which is essential not just for compliance, but also for debugging models, identifying hidden biases, and ultimately building trust with users and regulators.
The healthcare startup example mentioned in the source sounds like a fantastic positive case study showing these solutions in action.
It really is. So this medtech startup needed to train an AI model for diagnostics using highly sensitive patient health records from multiple different hospitals. Now, traditionally, they might have tried to get all those hospitals to send their data to a central cloud server for training. But patient data, that's under incredibly strict rules like HIPAA in the US and similar regulations globally. Centralizing it is usually a non-starter, legally and ethically.
Yeah, trying to centralize that kind of data would have been a compliance nightmare right out of the gate.
Absolutely. So instead, this startup used federated learning. They essentially sent their AI training software to each hospital. The model trained on the patient data locally, securely, behind each hospital's own firewalls. The raw patient records never ever left the hospital's control. Only the aggregated learnings, the mathematical updates to the model parameters which don't contain individual patient data, were securely sent back to the startup's central system to be combined, improving the overall model.
Wow. So the sensitive data stayed safe and sound within each hospital.
Exactly. This let them train a powerful diagnostic model using diverse data from multiple sources while fully respecting patient privacy and all the strict data residency rules. And the result? They sailed through compliance audits much more easily than competitors trying older, centralized data methods. This meant they could get their product developed, validated, and launched much faster.
That's a perfect example of privacy actually enabling innovation, not blocking it. By picking a privacy-first architecture right from the start, they turned a potential showstopper into a competitive edge that got them to market quicker.
That's the really critical takeaway from this whole section of the source material. Innovation and compliance are not destined to be enemies. By making smart choices about architecture and leveraging these kinds of privacy-preserving techniques, synthetic data, federated learning, differential privacy, clean rooms, explainability tools, companies can not only meet their obligations, but actually unlock valuable AI use cases that might have seemed too risky or just impossible before. It's about building AI that's respectful of privacy by design.
Okay, so we've got the technical toolkit, the methods to build this bridge, but just having the right tech, that's often only half the battle, especially in big companies, right? The source material also digs into the organizational side, the process stuff needed to actually make this work. How do companies get teams like legal, privacy, security, data science, engineering teams that maybe traditionally didn't talk much or saw each other as roadblocks to actually work together effectively on AI?
This is so crucial. You can have the fanciest privacy tech in the world, but if the different parts of the organization aren't aligned, or if the processes for working together are broken, it won't help much. The sources really emphasize that making this work requires deliberate organizational change.
So what are some of those strategies the sources mention that help break down those silos and get people working together?
One effective approach highlighted is creating joint task forces or specific cross-functional governance committees focused just on AI. These groups bring together people with expertise from all the key areas: legal, privacy, security, data science, engineering, the business unit involved right from the beginning of an AI project.
So instead of data science building something in isolation and then throwing it over the wall to legal hoping for approval, everyone's in the room from the start.
Exactly. It ensures that privacy, security, ethics, compliance, all those requirements are considered during the design phase. They get baked into the architecture and the data strategy from day one, not tacked on as an expensive afterthought requiring rework. It builds shared understanding and, frankly, shared ownership of the risks and responsibilities.
Okay, that makes sense. Another process mentioned is the Privacy Impact Assessment, or PIA.
Yes, PIAs are a standard tool in the privacy world, but the sources stress the need to mandate them and streamline them specifically for AI projects. A PIA is basically a structured process to identify and minimize the privacy risks of a new project before it goes live. For AI, this means carefully assessing things like what data is being used, how is it collected, how will the model process it, who gets access to the model, the data, the outputs, what's the potential for bias, how will we handle user rights like access or deletion.
So it's like a formal checklist to force teams to think through the privacy implications early on.
Pretty much. And by making PIAs a required step in the AI development process, and importantly optimizing that process, maybe using standard templates, clear risk criteria, even some automated tooling, you catch potential compliance bombs when they're still small and easy to diffuse during design or early development, instead of finding a massive problem right before you plan to launch.
Definitely sounds better than last-minute panic.
It is. The sources also point to the value of implementing robust data catalogs and access control platforms. These are really a combination of technology and governance. A data catalog acts like a library card system for your data. A central, searchable inventory showing what data you have, where it is, how sensitive it is, who owns it.
So people can actually find out what data exists and who's responsible for it.
Yes, which is surprisingly hard in many large organizations. Then, layered on top, access control platforms enforce the rules about who gets to access which specific data sets and for what purpose, especially for things like AI training or testing. Crucially, these platforms also provide detailed audit logs showing who accessed what, when. This directly tackles those SOC2 problems around sloppy access controls and sandboxes, and it helps fight shadow AI by making it harder for people to grab sensitive data outside of approved tracked channels.
It brings much-needed structure and accountability to how data gets used for AI.
Precisely. And finally, the sources highlight the importance of having clear, designated AI governance leadership. This means somebody, or some specific group, is officially responsible for overseeing AI governance across the company. It could be a dedicated role, maybe a chief AI officer with a governance mandate, or it could mean formally integrating AI oversight into existing roles like the Chief Information Security Officer, CISO, the Chief Data Officer, CDO, or the Data Protection Officer, DPO.
So having someone whose job it is to drive the AI governance agenda and make sure policies are actually being created and followed.
Yes. It provides focus, executive backing, and ensures AI governance doesn't just fall between the cracks of different departments. It signals that this is a real strategic priority.
And that telecom firm example sounds like a really positive case study, showing how these organizational strategies can actually make a difference.
It's an excellent example of how improving the process can turn governance from a perceived bottleneck into an actual accelerator. This major telecom provider realized their old way of reviewing AI projects, kind of decentralized, maybe a bit ad hoc, was causing long delays, especially waiting for legal and privacy sign-offs.
They were feeling that bureaucratic friction we talked about earlier.
Exactly. So to fix it, they set up a central, cross-functional AI governance center. But this center wasn't just about writing rules. It was about making governance work smoothly. They created a clear intake process for new AI ideas. They defined risk tiers, low, medium, high, with corresponding review paths. Lower risk projects could follow a faster, more streamlined process. They developed standard templates for proposals and privacy security documentation, making it easier for the development teams to know what was needed. And they provided training to help teams understand the process and build in best practices from the start.
So they basically built an efficient system around the governance function itself.
Precisely. And the results were pretty dramatic. By putting this structured, collaborative process in place, they slashed the time it took for legal and privacy reviews. The source notes review cycles dropped from an average of 3 months down to just 2 weeks for many projects, especially the lower risk ones on the fast track.
2 weeks versus 3 months. That's a massive speed up in their ability to actually get responsible AI deployed. It really shows that governance, if you design it smartly and collaboratively, doesn't have to be the brakes. It can actually become part of the engine, providing clear guardrails that prevent costly mistakes and rework, letting you move faster, safely.
It's a powerful demonstration that improving the process is absolutely key. The big takeaway here is that embedding governance and compliance into the actual workflow of AI development, getting the right people involved early, using structured processes like PIAs, using tools for data visibility and control, having clear leadership, it changes the whole dynamic. Governance shifts from being seen as a reactive no department to being a proactive partner that enables faster, safer, and more scalable AI.
So we've covered a lot of ground in this deep dive today. We started by outlining that fundamental tension. AI needs tons of data, but that data is sensitive and regulated. We looked at how that conflict plays out with specific challenges. GDPR and the crucial right to explanation, SOC2 demanding operational control, even in dev environments, data minimization potentially starving AI models, the sheer complexity of global data flows under rules like Schrems II, the friction from necessary but sometimes slow ethical reviews, and the real risks that pop up with shadow AI.
And we saw that the source material definitely doesn't just dwell on the problems. It points towards a clear way forward. It highlights those crucial technical tools, synthetic data, federated learning, differential privacy, data clean rooms, explainability frameworks as key enablers for building AI that respects privacy from the outset.
And critically, it emphasizes that the tech alone isn't the whole answer. Those organizational strategies, cross-functional teams, streamlined PIAs, good data catalogs and access controls, dedicated governance leadership are absolutely essential to align everyone and actually make responsible AI happen in practice.
Yeah, the core message coming through from this material is pretty clear. Trying to push enterprise AI innovation forward while ignoring data privacy and compliance, that's just not a sustainable strategy. It leads straight to legal trouble, operational failures, lost deals, damaged reputations, and ultimately innovation grinding to a halt.
And you can't really manage data privacy effectively in the age of AI without understanding the unique needs and dynamics of these powerful technologies either. They absolutely have to be tackled together as integrated parts of one strategy.
It really is about reframing compliance, not seeing it as just a burden or an obstacle to get around, but seeing it as a fundamental design constraint, kind of like how gravity is a constraint for an aerospace engineer. It forces everyone involved, engineers, data scientists, business leaders, to be more creative, more thoughtful, and ultimately to build AI systems that are smarter, more secure, more sustainable, and fundamentally more trustworthy right from the beginning.
So, the companies that are really going to win in the long run with enterprise AI, according to this perspective, they won't necessarily be the ones who just move the fastest by cutting corners. They'll be the ones who build deep trust by moving securely, transparently, and responsibly, making privacy and compliance part of their core operating model.
And thinking even bigger picture, building that trustworthy AI is just foundational for its long-term acceptance and success in society. If people don't trust how AI uses their data, or if it's constantly seen as unfair or risky because of privacy failures, you could see a real backlash that slows down progress for everyone.
Okay, so thinking about everything we've unpacked, this need for privacy by design, the vital role of getting different teams to work together, the idea of efficient governance actually speeding things up. Here's something to leave you with, something the sources prompt us to consider further. If building truly responsible and trustworthy AI really demands this deep integration of privacy and security right from the very start, how does that fundamentally change the culture that's needed inside companies? Going beyond just the tech teams or the legal department, what does it really mean for who needs to have a voice, who needs a seat at the table, right from the moment any new AI project is even conceived?
That's a great question. It really gets to the heart of the necessary organizational transformation.
Indeed. And that brings us to the end of our deep dive into this really complex but crucial intersection of AI innovation and data privacy in the enterprise. Thanks so much for joining us.
Thank you.
We'll catch you on the next one.